Good afternoon, everyone. We will start with a new topic today. This topic also belongs to third unit. In third unit, so far what we have seen is first we saw looping. Looping constructs while loop, do while loop, for loop, etc. Then we saw arrays, one-dimensional array and two-dimensional array. The third major topic in third unit 3 is structures. And structure is a user defined data type. So some time back we had seen that hierarchy, different types of or different classes of data types, built-in data types, then derived data types, then uh, user defined data type. So built-in data types: integer, character, float, double, etc. Okay. And derived data type: arrays are basically derived data type. It's a collection of elements of same type. So when we wanted to store large amount of data in memory of same types, okay, maybe 20 integers or 50 integers or 100 floating point numbers, instead of creating individual variables, what we did is we created arrays. Okay, but the basic data type was already available. Say integer was there, we created an integer array. Character is a built-in data type, we created character array. Likewise we did, the basic data type was there and we derived a new data type that is called an array, and this was allowing us to store large amount of data. Okay, individual variables, in one variable we can store only one data. So if we have three variables, say in a1, a2, a3, we can store only three integer data. But what about the situation where we need to store large amount of data of same data type? Okay, then we solve that issue with the creation of arrays. We created an array, stored a lot of numbers in that, and found the sum of those numbers or found the largest of those numbers, etc. We have seen. Now moving on, structures are allowing us to create our own data type. Structures are allowing us to create our own data type. So far we have not created our own data type. Integer was available, we derived integer array out of it. That's it. Structures are going to allow us to create our own data type. Now if the data type is available or we create a data type, using that data type we can create variables. Okay, that is the idea. Now what is the type of like new data type we will want to create ever? We take an example. Suppose I want to store the details of students of my class. In the computer memory I want to store the details of students of my class. The details may be the name of the student, or the CGPA of the student, USN of the student, etc. Now what is the solution here? If it is single students data, for the name I will create a character array. For CGPA I will create a floating point array. USN is another string, so I will create another character array. So for a single student I am going to create three variables. Okay, a character array. Okay, assume it is not single variable. A character array for storing the name, a floating point variable for storing the CGPA, and another character array for storing the USN. Assume that USN is an integer, then we will create an integer variable for storing the CGPA and USN, integer variable for storing the USN. Okay. Now what if I want to store the details of 50 students in my class? For one student, for CGPA I created an integer variable. USN is also assuming that it is or CGPA I created a floating point variable. Assuming that so one student int USN, assuming that USN is integer. CGPA float CGPA. Then name, character array I am going to create. Character array I am going to create for, say 20 is the length of the character array. I can store a name in this. Okay, this is for one student. One student. So one integer variable for USN, one for CGPA, one array for storing the name. What if I want to store the details, these details of 50 students in my class? 50 students in my class. So what I will, a solution from out of this, by extending these individual variables, what I will do, for USN I will create an array of 50 size. 50 size. So that I can create 50 USNs in this array. For CGPA, I can create a array CGPA made of 50 elements. Now, this character array is storing one name. I want to store 50 names. So, in that case, what I can do is, I can create a two-dimensional array of 50 size, 50 rows and 20 columns. Now, this is a two-dimensional array of 50 rows and 20 columns. So in each row I will be storing a name of at most maximum 20 characters. This is the way I can do it. Now if I want to store the details of 50 students into this array, USN into that is array, I have to individually pick up, say USN 0, I will store the first student's USN. USN 1, I will store the second student's USN. This way we have to individually process each element of USN array, CGPA array and name array. Name array is a two-dimensional array where one name is stored in each row. So this way of managing is very complicated. This way of managing is very complicated. Instead of that, what we could have done is, if we are allowed to create a new data type, I will prefer to create a new data type called student. I will prefer to create a new data type called student if I am allowed to do that. A student data type, and whenever I want to store details of one student, I will create one variable. Whenever I want to store the details of 50 students, I will create an array of 50 students. This is with an assumption that we have a data type called student. Once I have a data type, I can create a variable of that type. And for storing one student, I can create one variable of the student data type. Storing 50 students details, I can create an array made of size 50, so that each element in this array is one student variable, where I can store the details of one single student. So this way I can create. So this is the hypothetical scenario if this data type is available, but unfortunately the language does not provide a data type called student to store the student details. There is no data type called employee to store employee details. What kind of details we want to store? Similar details, USN, name, CGPA. For an employee, employee ID, salary, name, age, etc. So such data types are not provided by the language. But C programming language has given us a facility to create such data types. If we want, our program requires a new data type, the language is allowing us to create a data type called student. Since we are going to create such a data type, we call it as user defined data type. User is the programmer here. So we call it as user defined data type. So we had built-in data types like integer, then derived data type like arrays, and now we are going to have user defined data type. So what we do is, first we will create the data type. Then we create variables of that data type. That is the two step involved in this. In case of array, we had already this data type. Int was there. We created integer array. But in user defined data type, we have to create the data type first. And once the data type is created, we can create variables. Once we have variables, we can store data in that. Once we store data, we can process the data. So that chain goes on. Okay. So this is the fundamental idea of user defined data type. We are going to create our own data types. And the mechanism for creating user defined data type in C is called structure. Okay. So structures in C provides a better way to deal with scenario where we want to store complex data, details of the students or details of the employees. So instead of creating so many arrays or say so many individual variables or so many different arrays, we can create a new data type and we can create the variables of that data type or arrays of that data type. That is the idea. And since the programmer or the user creates that, here we are the users. As programmers, we are the users of the programming language and we are creating the program. So in that sense, we call them as user defined data types. Now when we create user defined data type, say student, we want to have different types of data. Say for one student, we have a name which is a character array, CGPA which is a floating point value, USN maybe a integer value. Different types of data is also there. So somehow we should be able to put together different types of data when we are creating a new data type or a user defined data type. So structures in C is allowing us to combine different data types to create a different existing data types to create a new data type. That is what structure is. Okay. Now what we are going to learn in this is how to create a new data type using structure mechanism. Once we create the new data type, how to create variables. Once we create the variable, how to store data in that, and as a natural next step, how we are going to access that data, process that data and find some output. Okay. Now the keyword used for creating a structure is struct. This is the keyword. This is the language specified word used for creating a new data type, struct. And this is the general syntax, and this is followed by the name of the data type. Okay. So rather showing the general syntax, first I will show the example. What if I want to create a new data type called student? Struct is the keyword. Student is the name we are going to give for the new data type. Just like int is the name for the integer data type, the name we are going to give for the new data type is int. Now what all fields or details about a student that we want to store when we create a variable, those will form the members of this structure. So we are effectively creating a structure or a user defined data type with the name student, and we open a curly brace and we close the curly brace here. In between the opening curly brace and closing curly brace, we are going to add the members or the details of the students we want to store. So I have name as one field for the student data type, ID as another field. ID is basically USN. Okay. Integer, I am assuming that integer to keep it simple. So ID, student ID and the CGPA. So these are the members of student data type, and we know that character is already available to us as a built-in data, and we are creating a character array here to store a name. Integer is another built-in data, float is another built-in data. So we use existing data types to create the members of the new data type we are creating. And student is the new data type we are creating. Any question? Any doubt so far? Once I create, say I put a semicolon here. Now my data type is ready. Once I create this data type, I can create variables of this data type. Just like I create integer variables, I can create variables of student. Any number of variables as student s1, s2, s3, or I can create an array of student data type so that I can store details of maybe 10 students, 15 students, 50 students together. Okay, so this is a very simple, basic, practically useful data type that we are creating. Since C programming is not providing us a data type called student, we are going to create it. Okay, now the general syntax is, now you can connect it actually. This is data type, this is the variable name, or sometimes it is a single variable, sometimes it's an array. So general syntax is like this: struct name of the data type, we had student as the example, then instead of integer data type 1, then name of the variable member. Here they are member variables of the data type we are creating. So this way I can add theoretically any number of member variables for my new data type created. Okay, and the syntax ends with a semicolon at the end. So this is to indicate that we can keep on adding more and more members for my new data type. So here student I am limiting to 3 members: name, id and cgpa. Suppose if you want to have age also, you put int age, that way another member. So this way theoretically I can add any number of members for my data type. Okay, hope it is clear. If not, please ask. Okay, so any question? Now what are the differences between array and a structure? Array we already studied, it is a derived data type. Once we have the data type, we can create an array of it, so that large number of variables are created in one shot. Array is basically a collection of variables of same data type created in one shot. Okay, now the difference between array and structure: collection of related data type. In an array we can create only elements of same data type. Say an integer array, we can store only integers. Character array, we can store only characters. Now a structure is a collection of different data types. Okay, now an array is normally derived from existing data types. If integer data type is available, we create an integer array. If since character data type is available, we are creating character array. Here structure is a user defined data type itself. We are creating a new data type from scratch. Okay, user defined data type itself. Array is derived from existing data types. Now in this case array, most of the time the basic data type, say integer, is already available, we create. In this case, in the case of array, most of the time we create the data type first, then create variables or array of the. So first step is to create the data type itself in case of structure, just like we created student data type. Once we have the data type, we can create variables or arrays out of that data type. But in case of array, already the data type is assumed to be existing. Int, char, float, double, etc. We create integer array or float array or character array, double array. These are the 3 major difference between array and structure. Okay. Now declaring variables of structures. There are different ways of once we have the data type, we have different ways of creating the variables. One is this is my structure. This is my structure. Now if I want to create a variable of this type, say my type is the name of the new data type. I am creating a new data type made of three members: integer, a character, and a float. One way of creating a variable is I create, say, s or s1. If I want to create one more variable, s2, like that I can create. This is one way of creating a variable, creating one or more variables of my data type. Okay, but there are more natural ways of creating it. So normally we may not follow this way of creating the variable. Rather than, what we will do is we first create a variable, data type, struct my type. Previously the example I showed was student, so I'm still making it more simpler. Struct my type, within the curly brace I am adding the members. So I have the liberty to add any number of members and any type of members according to the requirement of my application, my program. Application means program. So this, the name of the new data type is my type, and first member is an integer variable with the name n, then it is a character variable, then floating point variable, and the semicolon. So this is my data type. This is the definition of my data type, or the creation of my data type. Name of the data type is my type. Now if I want to create a variable of this, what I can do is, let's go into the main function. So normally the data type will be created before the main function normally. Okay, so once I have a data type ready, what I'll do is I'll create a variable. To create a variable, we again use the keyword struct followed by the name of the data type. The name of my data type is my type. Okay, my type. Struct my type and the name of the variable. My type is the name of the data type and followed by name of the variable. If I want to create one more variable, comma, name of another variable. Name of the variable, like based on the rules, we know how to name a variable. What are the valid names for variables, we know. So I can name anything. Okay, s1 or student1, student2, or whatever I can name. So this is very much similar to creating variable of built-in data type, int n1, n2. Here name of the data type is int. Here name of the data type is my type. That is the difference. Now since we are using struct, user defined data type, to indicate that we use the keyword struct also. So it will be struct my type followed by the variable names. In case of built-in data types, int is the name of the variable, data type. So we use int n1 comma n2. So it is very similar to how we create variables of built-in data types. Only thing is that we use the keyword struct, keyword struct. Okay, now my variable is ready. Just like integer variable, my variable is ready. How to store data into the variable? Once we are creating variables to store data. In case of my data type, s1 and s2 are the variables. I want to store data. How I can store is s1. If I want to store data in s1, I have to use s1.n. That means I should be accessing the members of my data type individually and store data into this. Now s1.n, if I dot is the operator to select the member of a variable, or a member of the user defined data type. So I have to use s1.n and assign 10. If I want to store value of c, s1.c and assign the value character. Since C is a character data, I am assigning the value one character value s1 dot f. Now when I do this, what happens is, when I do this, create the variable, what happens is memory will be allocated for this variable. We know that whenever we create a variable, some bytes will be reserved in the computer memory for that variable, and in that space reserved in the memory, we are going to store the actual data. Now when I create S1 in memory, this is the representation of the memory. In memory, the whole thing, this whole thing represents S1, variable S1 of the structure data type I created. And S1 will have members N, C and F. S1 the N, C and F are the members of S1. Now I can store a number here. So since I stored S1 dot N is equal to 10, what happens is N becomes 10. N becomes 10. 10 will be, since it is an integer variable, normally 4 bytes will be reserved. So this location is actually 4 bytes. I assign 10. When I do S1 dot C equal to A, in C, what will be stored? A will be stored. Because of this statement, A will be stored in C. And in F, 1.32 will be stored. This is one way of storing data into a structure variable. If it was a normal variable, we know how to store data. Int n1 is equal to 10. Or int n semicolon, later n1 is equal to 10. Now since this is a structure variable, the individual members of that structure, we have to store data manually, individually. So s1 dot n, when I do this, this happens. This n is stored with value 10. N is made of 4 bytes. You know that when a variable is created in memory, 4 bytes will be reserved for that. And C is character. It is made of normally 1 byte. So, and A will be assigned. F is floating point, normally 4 bytes in a machine. And when I do this, 1.32 is created. Now when I create S2, one more variable of my type is created. This is S2. And that also will have the members N, C and F. So here we have N, C and F. Similarly, here also we are going to have N, C, F. This N is member of this variable. This C is member of this variable. F is member of this variable S2. Similarly, this N is member of S1. This is member of S1. This also. S1 and S2 are totally two different variables, got its own memory. So here total memory of S1 is 4 bytes for this, 1 byte for this, again 4 byte for this. 4 plus 1, 5 plus 1, 9 bytes. Minimum 9 bytes will be reserved for S1. Similarly, S2 also minimum 9 bytes will be reserved for n integer variable n, integer member n, character member C 1 byte, floating point F 4 bytes. What you need to understand is S1 and S2 are two different variables of my type. Both of them have got their own memory allocation when they are created in the main function when they are created. Now this is how we initialize. This is again compile time initialization. I know the value, what value to be stored. Because of that, I am assigning it to the structure variable members. Okay. Now I have an assignment statement here. S2 equal to S1. What happens? Whatever value we stored in the members of S1, that will directly get copied into S2. Okay. So after the execution of this statement, what happens is same thing, same data. it will become, or yeah. So when this is performed, whatever values are there in the members of variable S1, structure variable S1, that will be copied into S2. That is going to happen. So what we have seen so far is how to create a user defined data type. Then how to create variables of my new data type. Then during compile time, how to store data. If we know the values of the member variables, how to directly assign s1 dot n, s1 dot c equal to s2 s1 dot f. Similarly, I could do for s2 also. Instead of that, what I did is whatever data I stored in s1, I copied into s2. Now I am printing it. I want to print the values stored in the structure variable s1. What I need to do is I have to individually access the members and print it. s1 dot n, s1 dot c, s1 dot f. If I do s2 dot also, the same data is going to be displayed. If I do s2 dot n also, since I am copying all the content of s1 into s2, so s2 data is s2 dot n is also going to print the same value. Or s2 dot c is going to print a, s2 dot f is going to print 1.32. Is it clear so far? Any question? Any question? Okay, if not, I am assuming that you understood it, and moving ahead, there are some other ways of initialization also. So here what I did, I access the individual members and assign the value. Instead of that, another way of compile time initialization is directly I provide all the three data. We know that my type is made of integer, character and a floating point member. Now integer value, since my type first member is an integer, I have to put an integer here. Then second member is a character, so I put a character. So if I do this also, the same effect is going to happen. The same as doing this, but in one stretch, in one line we are able to write that. So this is also a valid syntax. Struct my type variable name equal to the three values. Okay, then this already we have seen. My type s1 s comma s3 I created, then assigning values into this. Okay, these things we have seen already in previous example. We have seen this assigning to s2 members, then s2 is totally copied into s3. Here three variables are there. Here we created two variables of my type. So this way, since my type structure is defined, we can create any number of variables or even arrays. Okay. Any question? This so far we have seen the theoretical aspect of it, and we can see the programs also now. Any question? Normally people find little difficulty in understanding the concept of structures. So if you have any question, anybody, please raise it. So if you have a doubt, that means many others are also having, just that they are hesitant to ask. No question? Okay. So we are going to now see practical examples of creating structure variables, structure data type, and variables of those data types, and how to store data, etc. Okay. My first example is same thing, same example I am showing. Just now I showed. This is my structure. Struct. I'm keeping the structure very simple. I could have a character array and all, but initially I'm keeping the structure very simple. Struct is the keyword. This is the name I am giving for my data type, new data type, my type. Okay, I can give something else also. Okay, it is up to me. So here, since I am not creating a real application data type just like student or employee, I randomly put some members. So this is the new data type I created. Name of the data type is my type. I'm creating a variable and directly initializing the data compile time. So what will happen is S1 will have three members N, C and F. Similarly, S2 also will have its own N, C and F. S3 also will have its own N, C and F. This is what we have seen here. S1, S2. S1 has its own existence with three member variables. S2 also has its own existence, physical existence in the computer memory with three members. Now I created two more variables. Okay, I'm going to execute this in debug mode so that you have a picture of what is actually happening in the computer memory. See, I have three variables S1, S2 and S3. S1, S2 and S3. And each of them are having members N, C, F. Similarly, S2, N, C, F. S3, N, C, F. These three, S1, S2, S3 are three totally independent variables. Got its own memory, minimum 9 bytes here. Okay, here also 9 bytes, minimum 9 bytes I am saying. Sometimes so for bookkeeping it will allocate some more additional bytes, that's why I say minimum 9 bytes. So it can be sometimes 12 or some rounded numbers, multiples of 2 or 4 rounded numbers. So minimum size will be 9 here, minimum size will be 9 here also, here also. Now so far what you are seeing is some random data. I have not initialized. See, this statement is not executed yet. A yellow arrow means it is going to execute. Okay, so if I press F7, executed. So N gets 10, C gets A. The ASCII value for A is 97, the integer representation. So it's 97 or A. Then F gets 2.57 I have put, but when it is storing it is as a like 2.569999. Normally when you are storing an integer floating point number, real number, in memory it may not be exactly storing it as 2.57. It will be like a large precision but very close to 2.57, 2.56, 9999 etc. So all the practical purposes it will be rounded off to 2.57. Since it is after 2.56, after so many nines, it is stored that way. So you don't need to worry about that. So whatever I am providing, that is now stored into my S1 variable into the member variables. Now S2.n I am going to do 20. S2.n. What happens here? See, it's 88 now. When I am executing that statement, it becomes 20. B 4.38. 4.38 is stored as 4.38000011. Okay, don't worry about that. Internally, computer does some inaccuracy. Whenever real numbers are stored in the computer memory, some small inaccuracy will be there. But practically, it will not matter for our program. Now what I am going to do is S3 equal to S2. Whatever we stored in S2, we are going to directly store into S3 also. S3 is now having some random values. When I do this statement, S3 also gets a copy of S2. Now printing the values of S1 variable. So individually I cannot put print S1. For user defined data type, the printf function is not supported directly. But if you access the individual members which are built-in data types, we can print it. So instead of there is no way to print S1 directly, the content of S1 directly. Instead of that, what we do is access the individual members of S1 and print it. So if I do this, you can see the values are appearing here. Okay. Again, if I do the second statement, values of the second variable, structure variable. Third variable is a copy of the second variable, so we get the values there also. So creation of the new data type, creating variables, compile time initialization. Here also we do compile time initialization because we know the values, or we assign the value directly. During compilation time only we know the values, so we assign directly. But practically this is not useful. We have to get the data from the user, right? So for that we'll see another program. Okay, yeah, here the example is a real world data type, useful, practically useful data type. Student I am creating. First member is a array, second member is a single integer variable, third is again a real number or floating point variable. So when I create this, create a variable of that type, what happens we'll see. Okay, so I'm going to execute. So breakpoint I put here because the execution starts from main. Okay, this is just the definition of my new data type, definition of the my new data type, or how the new data type look, or the plan or design of my new data type. The actual creation of variables are going to happen here, from here. So if I do this, shift effect, okay, see, s1 is there. I created s1 struct student s1, and for first value, which is a name, I am putting a string as the initial value, and US ID 1014, CGPA 9.35. So when I execute that statement, here now random values are there, name, ID, and so when I execute that statement, I get Amit as the name, followed by some termination characters. Actually the value is Amit, that is coming there. Follow and ID 1014, then 9.35000038. Okay, some precision inaccuracy is there. Now I'm printing it back. So I get Amit 1024 9.35 as the output. So since it's Amit is a name is a string or a character array, I am using percentage %s. ID is a integer, so I use percentage %d. CGP is a floating point value. Since I want to print it with the 2-digit precision, 0.2f I used. Okay. Here also we did not accept the data from the user, but practically this is less useful because we are not taking the data from the user during the execution time. So next program, probably let's see what it is. Yeah, here we are accepting the data from the user. Okay, normally when you are doing lab program and all, you will have to take data from the user. Now my data type is student, struct student. Members are same, name, ID, and CGPA. I am creating the variable of my new data type. The only change is that you have to use the keyword struct compared to built-in data types. So built-in data type means the data type name followed by variable name. Here, since it is a built-in data type, in C we have to use struct and the name of the data type followed by the variable name. Okay. Now I created the variable. Now you want to take the data from the user directly. How we do is, again we make use of the dot operator. So if I want to read name from the user in scanf, this is very similar to our built-in data types also, or arrays or built-in data types. But here we put s1 dot name. Since name is a character array and what we are reading is a string, ampersand is not required. But if I want to read id, which is an integer, ampersand s1 dot id. So the data will be received from the user and stored within the s1 variable into the member variable id. So s1 dot id. And since we are reading only one value into one variable, we are using ampersand. So this difference, when it is a character array and we are reading a string, we were previously also we were not reading using ampersand. Similarly, here we don't use ampersand because name is an array. Here id is an integer variable, we use ampersand. CGP is an integer variable, we use ampersand. So we are going to we are reading it from the user. After that, how I am printing? Again s1 dot name. Even though it is an single variable, when printing we don't need to use ampersand. So s1 dot id, s1 dot cgpa, separated by commas. Okay. Then using size of operator, I am printing the size of my new data type. Just like size of integer, size of my new data type I am printing. Okay. Now if I execute this program, I have to enter three data now. Rohan, ID or USN 9.23. Okay. So this scanf statement reads the data I entered and stores in S1. Specifically in the members of S1. S1 dot name. Rohan will be stored in S1 dot name. 1024 will be stored in S1 dot ID, and S1 dot CGPA. The CGPA value will be stored. The value details I entered. These are the details. Then I am simply displaying it back. Then size of the data type is 60. It is showing 60. Why is it so? S1 has a member array of 50 size. It's a character array of 50 size. So 50 bytes. Since it is character, 50 bytes. 50 bytes. Now integer requires minimum 4 bytes. This also requires 4 bytes. Total 58. So minimum, I told always minimum 50 for my size of my structure data type is minimum 58, but internally compiler will round it off to 60. Okay, compiler is rounding it off to 60. That is why we are finding it as 60 here. Because minimum can be 58, but it need not be always the case. For some internal optimization, compiler will put some additional 2 bytes there, kind of rounding off, I can say, kind of rounding off. Okay, with that we will stop for the day. We will continue in the next class. Hope it till now these things are clear. You can read the notes and come back to me if any doubt is there. Thank you. We'll stop the class today.